Hello everyone and welcome to The Explainer. Today, we're diving into something really cool in chemistry, something you literally see every single day, the states of matter.
Okay, let's kick things off with a little bit of a puzzle. I want you to think about a hard, cold block of ice. Then think about a glass of water you can drink. And finally, that invisible steam that comes off a hot cup of tea. They seem completely different, right? I mean, one is hard, one flows, and one you can't even really see. But here's the amazing part. They're all the exact same substance. They are all just water. So how is that even possible? How can one thing exist in such different forms? Well, that's the big question we're going to answer today.
So the answer to that puzzle lies in something we call the states of matter. It's pretty simple, really. Most stuff can exist in different physical forms, usually depending on things like temperature. And these different forms, well, those are the states of matter.
Now, we're going to focus on the three big ones you absolutely need to know: the solid state, the liquid state, and the gas state. Solid, liquid, gas. Got it? Awesome. Let's break each one down.
All right, let's get into it, and we'll start with the one that's firm and steady, the solid state.
So what makes something a solid? It really comes down to two key things. First, it has a fixed shape. Think about it. A book is always book-shaped, whether it's on your desk or in your backpack. Second, it has a fixed volume. That means it takes up the same amount of space no matter where you put it. The shape and the space it fills up, they just don't change.
And you are surrounded by solids all the time. I mean, seriously, look around. The ice in your drink, a stone on the ground, the wood your table is made of, and of course the book you're reading. All of these things hold their own shape and their own volume.
Okay, next up, we have liquids. And this is where things start to get a little more interesting. See, unlike a solid, a liquid does not have a fixed shape. It's totally happy to take the shape of whatever container you pour it into. Pour water from a bottle into a glass, and bam, it's the shape of the glass. But, and this is super important, it does have a fixed volume. 1 liter of water is always going to be 1 liter of water. It doesn't matter if it's in a tall, skinny bottle or a wide, flat bowl.
And just like solids, liquids are absolutely everywhere. The water we drink, the milk you have for breakfast, the oil used for cooking, the juice you enjoy on a hot day. They all flow and change their shape to fit in.
And finally, we get to the most free-spirited state of all, gas. You could say a gas has basically no rules when it comes to shape or volume. It has neither a fixed shape nor a fixed volume. It will just expand and expand to completely fill up any container you put it in, no matter how big that container is.
Just think about the steam from a boiling kettle. It doesn't just stay above the kettle, it spreads out into the whole kitchen. The air all around us? That's a gas. The oxygen we need to breathe? Also a gas. Even the LPG used for cooking is a gas that's just been squished into a cylinder. You might not always see them, but they are definitely there, taking up all the space they can.
All right, so we've looked at each state one by one. Now, let's do the fun part and put them all side by side. This is where you can really see the differences clearly.
This is where it all starts to click and make perfect sense. Okay, check out this table. What's so cool about this is how simple the pattern is. Look here. Solid, fixed shape, fixed volume. Super easy. Liquid, it gives up on having a fixed shape, but it hangs on to its fixed volume. And gas, it just lets go of both. No fixed shape and no fixed volume. You know, this table is incredibly useful, especially for your exams. It's the perfect summary, so take a good look.
So now we know the what. We know the properties of each state. But what about the why? I mean, why do they behave so differently? Well, the secret is all about the tiny little things called particles and how they are arranged.
In a solid, I want you to imagine the particles are like soldiers standing perfectly in formation. They are packed incredibly tightly together. They're kind of vibrating in place, but they can't actually move around. And this makes perfect sense, right? It's why solids have a fixed shape and volume, because their particles are all locked in.
Now, in a liquid, the particles are more like a crowd of people at a concert. They're still pretty close, but they've got enough room and energy to slide and tumble past each other. This is exactly why a liquid can flow and take the shape of its container. But since the particles are still close, you can't really squish them together, and that's why the volume stays fixed.
And then you've got gases. For gases, picture the particles like a bunch of super energetic kids in a giant empty playground. They're really far apart, and they're just zooming around randomly at crazy high speeds, bouncing off everything. This is why a gas expands to fill any space you give it.
There's basically nothing holding its particles together at all.
All right, that was a whirlwind tour of the 3 states of matter. Let's wrap things up with the most important points that you should definitely take away from all this.
So what's the bottom line? We learned about the 3 main states of matter: solid, liquid, and gas. We dug into their unique properties, shape and volume. We compared them directly, and we saw tons of examples that are all around us in our daily lives.
And you know what? This brings us right back to our original puzzle with the ice, water, and steam. The big idea I want to leave you with is this: states change, matter remains the same. By adding or taking away energy, usually heat, we can change the state. But the stuff itself doesn't change. It's still water. It's just wearing a different outfit. Pretty cool, huh? So what other things can you think of that do the same? Thanks for watching.